All right, so I want to get into the quadratic formula, but before I do that, I want to show you guys where the quadratic formula comes from and why it's not just something that just came out of the sky, right? There is a logical explanation for why the quadratic formula is what it is and why it works. So here's an example of just a general quadratic equation, ax squared plus bx plus c equals 0. Don't need to know what a is, don't need to know what b is, don't need to know what c is. Let's use completing the square to find a general solution for a standard form quadratic equation. So first step in completing the square is if your a is not 0, let's divide everything by a. So let's just assume a is not, first step is if a is not 1 or negative 1, then divide everything by a. Let's just assume that a is anything else other than 1 or negative 1. So I'm going to divide that out here, 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 and here. So a's cancel out. X squared equals b over a times x plus c over a equals 0. So first step of completing the square, done. Next step is to make sure all of your variables are on one side and everything else is on the other side. So that's c over a. We're going to move that over. We're going to subtract c over a on both sides. That gives me x squared plus b over ax equals negative c over a. Okay. Now comes the actual completing the square part. So b over a is my new b. So that means I need to find my new b over 2 squared. So my new b over 2 is b over a over 2, which, if you know how to divide fractions, it's b over a times 1/2, which is b over 2a. So when I complete the square and I factor the perfect square trinomial, that's going to be part of the factor. But now I need to go ahead and square it, right? So that's x squared plus b over a x plus b over 2a squared equals negative c over a plus b over 2a squared. All right? So now, here, I have a perfect square trinomial now that I've completed the square. And so that's going to factor to x plus b over 2a squared. Now here, what I want to do is I want to expand this. So that means I'm going to multiply this by itself. And then I'm going to combine them together with a common denominator. So if I add those together, b numerator times numerator, denominator times denominator, I have b squared over 4a squared. And I want to give this right here a common denominator. So to get to 4a squared, I multiply the denominator by 4a, all right? So if I multiply the denominator by 4a, I also need to multiply the numerator by 4a. So 4ac. And remember, that's still negative. So now I can go ahead and combine them. To one fraction. So I'm going to do that on this side. Because this is addition, I'm going to go ahead and just move this to the front here. So that way my front end is positive. So that's b squared minus 4ac over 4a squared. Okay. So again, our first step was to divide by a. Second step was to move our constant terms to the other side. Then we completed the square. Then we factored. Then on to step 5, which is to take the square root on both sides. Okay, so that square root's going to cancel out that exponent. Okay, and now I can simplify this a little bit by taking the square root of this, because this right here is a perfect square. Because again, we literally had to square 2a to get this. Okay, so this is going to come out even, but I'm still going to use a square root in the denominator because I don't know what the square root of this is. It may not even be a perfect square. All right. Also, don't forget when you take the square root to solve an equation, don't forget that plus or minus. Okay. Square root of b squared minus 4ac divided by 2a. Remember, 4a squared is a perfect square. Only one thing left to do. Solve for a. We're going to subtract negative b over 2a on both sides. But now look what I have here. I have a common denominator. I can just go ahead and straight to combining them into one fraction. And then so I end up with x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And that is where we get the quadratic formula from. It comes directly from completing the square so that it gives us a general form of what our answers to quadratic equations in standard form look like. And it doesn't matter what your A is, doesn't matter what your B is, doesn't matter what your C is. This formula works for every quadratic equation. Okay, just as long as your coefficients are real numbers, you can use that for any quadratic equation. Okay, I have a couple examples up here. Now they're going to look the same. They look pretty much the same, except the value of C changes. And there's a reason why I've only changed the value of C for these examples. We'll explain that. We'll explain that a little bit later as we go. Okay, but for now, let's go ahead and look at the first one. For the first example, 4x squared plus 4x plus 2 equals 0. We're going to use the quadratic formula to solve that equation. Okay, so let's keep in mind, anytime that we're looking at a quadratic equation, we want to figure out what our A, our B, and our C are. So here, my A is 4, my B is 4, my C is 2. So let's go ahead and find the solution to this equation. Okay, so that is x equals negative b, so that's negative 4, plus or minus square root of b squared minus 4 times a times c, all divided by 2a. All right, now a common mistake that I see students make all the time is they only put the square root of this under 2 over 2a. Everything has to go over 2a, and that's exactly because of what I just showed you on how the quadratic formula is derived. Okay, make sure that you put everything over 2a. In this case, my a is 4. Okay, so let's simplify this. Negative 4 plus or minus square root of 4 squared is 16. 4 times 4 is 16. Times 2 is 32. So that's 16 minus 32. 2 times 4 is 8. All right, so that's negative 4 plus or minus the square root of negative 16 over 8. Okay. Now, a little while ago, we talked about complex numbers, so we now can figure out a solution to this by removing the negative here and putting an I behind that square root. And 16 is a perfect square. Square root of 16 is 4. So this is going to reduce to negative 4 plus or minus 4i over 8. Okay, we're still not done yet because now, just as we talked about with complex numbers, because I have a complex number solution, I have to write it as a complex number, a plus bi. So that means I have to split this fraction up. So that's negative 4 over 8 plus or minus 4 over 8i. And of course, you want to reduce your fractions. So my solution ends up being negative 1/2 plus or minus 1/2 times I. So there's my solution here. Okay. Let's go to the next one. So again, pretty much almost the exact same problem. Same A, same B, but this time my C is 1. Let's see what happens when I try to use the quadratic formula to solve this one. Negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. Okay. 4 squared is 16. 4 times 4 is 16. Times 1 is 16. 16 minus 16 is 0. And 0 is a perfect square. Square root of 0 is 0. Okay. So it looks like I have 2 solutions, but if you really look at it, I have negative 4 plus 0, which is the same thing as negative 4 minus 0. So I don't actually need to write it out as 2 solutions. I can just write it as one solution because, again, negative 4 plus 0 is the same thing as negative 4 minus 0, which is negative 4. There's my solution right here, negative 1/2. All right. Now let's go to our last example. All right, same A, same B. But this time, instead of my C being 1, now my C is -1. So let's see how that affects this problem. All right, so negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. Okay? 4 squared is 16. 4 times 4 is 16. Times -1 is -16. So minus -16 is plus 16 divided by 8. That's -4 plus or minus the square root of 32 over 8. Okay? Just like we talked when we talked about completing the square, when we're taking square roots to solve equations, we have to simplify our square roots, meaning that we need to look to see if the number inside of the square root has a factor that's a perfect square. So if I look at 32 and I look at its factors, 1 and 32, 2 and 16, 4 and 8. We're not going to use 1, so we're going to look at the other 5 factors. There are 2 factors of 32 that are perfect squares, 4 and 16. Anytime that you're using this method to simplify square roots and the number inside has more than 1 factor that's a perfect square, you always want to go for the larger one. Because that way you're guaranteed that your square root will be fully simplified in just 1 step. So again, square root of 32, right? 16 times 2. Well, because it's multiplication, I can split that up. Square root of 16 times the square root of 2. We know that the square root of 16 is 4. So this ends up being -4 plus or minus 4 square root of 2 over 8. But hold on, we're still not done yet. Because now I still need to try to reduce this fraction. Look at these 2 terms. Both of these terms have a 4 in it. This 8 is also divisible by 4. So I can factor out a 4 in the numerator and the denominator to reduce that fraction. So when I do that here, so that's 4 times -1 plus or minus the square root of 2. And then 8 is 4 times 2. So these 4's will cancel. My solution will end up being -1 plus or minus the square root of 2 over 2. There's my solution set right here. So 3 different quadratic equations, all with minor changes, but 3 different types of answers. Now, how is that? Well, it's not just the fact that I changed the value of c. It all has to do with the value that's inside of that square root. Because really, when we work the problem, that's the only difference, is that the value inside of the square root is different. And that can actually tell us a lot about how many and what kind of solutions a quadratic equation will have. So in the quadratic formula, this right here determines what kind of solutions your quadratic equation will have. That b squared minus 4ac is known as the discriminant of the quadratic formula. And just as you saw in those examples, there are 3 cases for the discriminant that helps show what kind of solutions your quadratic equation will have. So here's the first one. If your discriminant is negative, just like it was in this example right here, that means I have a negative inside the square root, which in turn can be simplified to become a complex number. So if my discriminant is negative, then your quadratic equation will have 2 distinct non-real complex solutions. And we have to be specific here. We can't just say there are 2 complex solutions, because if you really think about it, you can write a real number as a complex number. So we have to specify that it's a complex number that's not real. But also, they are distinct from each other. -1/2 plus 1/2 I is not the same as -1/2 minus 1/2 I. They are 2 distinct complex numbers. Okay? You have a complex number and its conjugate. All right, so if your discriminant is negative, the equation has two distinct non-real complex solutions. Second case, if your discriminant is equal to 0, that's what we saw in this example right here. Then your quadratic equation will have one repeated real solution. And you saw it here. The square root of 0 is 0. And -4 plus 0 is the same as -4 minus 0. Technically, there are two solutions, but they're the same number. That's why I didn't write it as two separate ones, because it ended up being the same number. -1/2 is the solution for it, but it's repeated. Another fun fact, if your discriminant is 0, that also means that your quadratic function in this equation is a perfect square trinomial. And you can factor it as a perfect square trinomial. Last case, if your discriminant is positive, kind of like what we saw in that last example over there. If your discriminant is 0, your solutions are going to be very similar to the first case. Instead, the difference being that your solutions are not going to be non-real. They are going to be real number solutions. So if your discriminant is positive, then your equation will have two distinct real solutions. Okay? Two distinct real solutions. Three different cases for three different types of solutions a quadratic equation will have. Now we'll bring up one last thing in terms of this right here. Now let's say my discriminant wasn't 32. Let's say it was a perfect square. Let's say I ended up with this. Okay. Well, first off, I know what the square root of 16 is. It's 4. I still have to simplify this. I can't leave it unsimplified like that. So the key to solving a quadratic equation, especially if you have either two non-real solutions or two real solutions, you have to simplify that fraction as much as possible. Okay? So here, I have to calculate -4 plus 4 over 8, -4 minus 4 over 8, right? So that's 0 over 8, which is 0. This is -8 over 8, which is -1. You have to go all the way. You have to simplify as much as possible, okay? Also, another quick tip. So we talked about how when your discriminant is 0, then your quadratic function is a perfect square trinomial. Well, perfect square trinomial is factorable, so we can actually extend that to, let's say that my discriminant is not only positive, but it's also a perfect square. If that's the case, then your quadratic function is factorable. So whatever quadratic function that came up with this discriminant right here, that tells me that the function for here that I'm trying to solve from here it can be solved by a factor. Now, not every quadratic function will be able to be worked out like that. But again, that's just an example of how the quadratic formula works for pretty much any and every quadratic equation, whether it's factorable or not.